Okay, here we're looking at section 9.2. We're going to start solving quadratic equations by graphing, and that's our first learning target for today as well, is to solve them by graphing. Then we're going to be using graphs to find and approximate zeros of functions. So when we're doing things by graphing, most of the time we have to approximate because we can't know mathematically for sure where we're at, but we can get a really good picture of what we're looking at. Then our third learning target is to solve real-life problems using graphs of quadratic functions. So here's the steps that I do by solving quadratic equations by graphing. And remember that a quadratic in standard form looks just like this. I have that squared variable as well. So the first thing I want to do is I want to write my equation in standard form. So then I graph the related function, right? I graph my function, and then I find the x-intercepts. So this has us going into standard form first, but often if we go there, if you are given something in intercept form, right, that helps us as well. So we're going to use all the information we learned in Chapter 8 about graphing those quadratic equations to help us in this section as well. And remember that we said that roots are the same thing as solutions, are the same thing as intercepts, right? All of those three words are synonymous or mean the same thing. So my solutions are the x-intercepts of my graph. So now let's look at this first example. So I want to solve x squared plus 2x minus 3 by graphing. So first I get it into standard form, so I get everything over to one side. So I write the original equation, and I'm subtracting 3 from each side to get everything equal to 0. So then I can graph my function, right? And I go ahead and I find my vertex, right? And in order to find my vertex, I use my negative b over 2a. That finds the x value of my vertex, and then I plug this back into my equation to find the y value of my vertex. And then I pick a couple more points, and I continue to graph, right? Or I can factor like we did back in Chapter 7, and that's probably going to be the easiest way to help you. So you always want to find your vertex, and then I would factor and find the x-intercepts. So from my graph, I see that my x-intercepts are at a negative 3 and a positive 1. That's the place where my graph crosses the x-axis. So my solutions are x equals negative 3 and x equals 1. So now I can just double check. I put these both back into my original equation, and remember I always use my parentheses, and they both end up working. So they both are valid solutions there. So now here are a couple I want you to try. Make sure that you can first graph them and then see what we're looking at. So now here's our next example. We're going to solve x squared minus 8x equals negative 16 by graphing. So the first thing I want to do is write my equation in standard form. So I write my original equation. Then I'm going to add that 16 to both sides. And now I can go ahead and graph my function, right? And go ahead and use this information from Chapter 8. How would you graph this, right? We're going to continue to use all of these things we've learned about quadratics as we continue in these units. So once I've graphed this function, I see that it looks like this. So I see I have only one x-intercept here. My graph crosses my x-axis on only one point, and it's at my vertex. So the x-intercept is my vertex here, and it's at the point 4, 0. So this quadratic has only one solution, right? In this previous example, I had two solutions, right? Because it crossed in more than one place. But in this example, this only has one solution. So that's possible as well. I don't always have to have two solutions for my quadratics. So let's look at this example too. So I want to solve negative x squared equals 2x plus 4 by graphing. So the first thing I do is I write it in standard form, and then I graph it. And here's what it looks like, right? So once I graph this, I see that my equation is way up here. Okay, so I see that it doesn't actually cross my x-axis. So there's no solutions for this one. Eventually we'll get into some imaginary solutions in Algebra 2, but for now it doesn't have any real solutions because it never crosses my x-axis. The other way I can do this is I can graph each side of my equation, right? So I've got two sides of my equation. So I can graph my left side, y equals a negative x squared, and then I can graph my right side, y equals 2x plus 4, and I see here this negative x squared and 2x plus 4, and I can see that these graphs don't ever connect, right? They never meet, so I can also say that there's no solutions, right? And remember when we were talking about systems of equations? Here's a system of equations with a quadratic and a linear equation, and we know that solutions are where those two graphs or those two equations meet. And here we don't have any of that, so again, I have no real solutions for this one. So try a couple of these and see how many solutions you can find, right? There's three possibilities. I can have no solutions, where my graph does not touch my x-axis at all. I can have one solution, where I have my x-intercept as being my vertex, or I can have two solutions where my graph crosses in two different places. So here's our next example, right? We're going to be finding the zeros of functions. We're using our graph to find the zeros, right? And I'm given the graph and I'm given the equation, so I'm asked to find the zeros. And remember, zeros are the same thing as solutions, which are the same thing as intercepts. So I see my intercepts are at -1, 2, and 3, and I can just see that from the graph. So the zeros are that -1, 2, and 3. And I can just double check by plugging all of these back into my equation, and I see that they all end up equaling 0, so I know I was right. It's really pretty simple when you're given the graph to just eyeball it and say, oh, my solutions look like they're at -1, 2, and 3, and then you just go and double check and say, yep, I was right. So here's our next example. We're going to be approximating, because if I look at this graph, it does not look like my graph crosses at any of the hash marks, so I know I'm going to have to approximate this. So first thing, I always graph it and see what I'm looking at. So I see that my first intercept is between -3 and -4, and my second intercept is between -1 and 0. So then I can make some tables using those x values between this -4 and -3 and between -1 and 0. And I want to use increments of 1/10, right? And I'm using this tenth because that's what I'm asked to approximate to. I want to look for a change in the signs of the function value. So let's see what that actually looks like. So if I start with my -3.9 and -3.8, right? These are all in my increments of my tenths. So my 0.1. And I definitely want to use my calculator to solve these. Right? So I see my f of x values. I see I have a positive value, a positive value. Oh, now I go to a negative value, so I have this change in signs, right? I went from positive to negative. That tells me that I've crossed the x-axis. So now let's look at our second grouping, right, where our second intercept was. So I started at -0.9, and again, I still have my same increments, and I plug these into my calculator, and I see I still have negative values down here. Oh, and then all of a sudden I change my signs, so this tells me that this is going to be where my other intercept is. So the function values that are closest to 0 correspond with the best approximate. So of these two, right, this -0.3 is closer to 0 than this one is. So I'm going to use this as my approximation of that function. So my zeros are about -3.7 and -0.3, right, because those are closer to 0 than the other one where I changed signs. So that's just how we can use our graph to approximate what our zeros are. So now here are some monitoring progress. See how you can do. First thing I want you to really look at number 11 is to approximate. First kind of figure out where we're looking at, and then use your math to help you actually determine for sure what the zeros would be. So here's our real world problem, our real life application. So a football player kicks a football 2 feet above the ground with an initial vertical velocity of 75 feet per second. So the function h equals -16t squared plus 75t plus 2 represents the height in feet of the football after t seconds. So I'm supposed to find the height of the football each second after it's kicked, and then use those results to estimate when the height of the football is 50 feet. Then using a graph, after how many seconds is the football 50 feet above the ground. So the first thing I want to do is I want to make a table of values starting with t equals 0, right? Because that's right when I kick the ball. And then I'm looking at every second. So I'm going to use my increments of 1. And I'm going to continue that table until my function value is negative, right? And I know that we can't actually have a function value that's negative because that means it would be below the ground. But that tells me right when it hits the ground again. Okay? So I go ahead and I make my table, starting at 0 and going in my increments of 1. And I plug those t values into my equation, always using parentheses, and I simplify and solve it from there. So here I can see the values of my h, of my height, at each of those seconds. So the height, and I was asked to find it after each second. So after 1 second, we're 61 feet. After 2 seconds, it's 88. 3 seconds, 83. 4 seconds, it's 46. So now I can estimate, now I'm looking at when is the ball 50 feet high. Okay, so using this table, I can estimate that the ball's 50 feet between 0 and 1, right? Because 50 is in between these two numbers. And then it's also going to be 50 again between 3 and 4 seconds. So based on those function values, it's going to be slightly less than 1 and slightly less than 4 feet. So I can also use a graph to help me determine this. So I want to write the equation in standard form, right? And I want to know when it equals 50, right? Because that was the part that was given to me. So I write it in standard form. So I subtract that 50 from each side. Then I use my graphing calculator, or I use Desmos, either one, to help me graph this function. And here's a picture of what it will end up looking like. And then I can use the zero feature. There are ways to find the zeros. On a graphing calculator, there's actually a button that says 0. And on Desmos, if you click on it, it will help you find exactly where it crosses the x-axis. So I use that graphing calculator to help me find my zeros. And you see it is just less than 1 second and just less than 4 seconds. So the football is 50 feet above the ground after 0.8 seconds and about 3.9 seconds, which is what we had gathered from when we just looked at the table, right? So we know that our data is correct because it's pretty close to what we had assumed it was going to be. So now here's the last thing I want you to think about. How many seconds is the football 65 feet above the ground? See if you can first estimate using your data table, and then what if we graph it? What's it going to look like from there? So now let's look back at our learning targets. So the first one was to solve quadratic equations by graphing. And that's really, we always just kind of get it into standard form and then graph it and then see where my zeros are. Then I was able to use those graphs to find and approximate my zeros. I always want to approximate first and then use the math to support my approximation. And then I could look at some real-life problems using those graphs of quadratic functions and solve for other variables. Now that we've done this, go ahead and work on this homework for 9.2.